This conference will now be recorded.
So what it covers really is some of the lessons learned. Sorry, I'll start again. So today's presentation is called Long Timbers and the Long Route to Success. So it covers some of the lessons learned through kind of our journey of understanding long timbers and how these have kind of influenced changes that are going to be implemented in the inspection and the management of these assets in future. And the reason I chose the title kind of Long Timbers and Long Route to Success is because this really is a long journey. I know before my time there was years and years of kind of experience and learning that went into the design and the management and the maintenance of long timbers. And it's been really exciting for me over the last couple of years to try and pick up on that and hopefully take us to a new place with long timbers and the design, management and maintenance of them as well through the standards and that kind of thing. So the presentation, it's about 12 slides and about half an hour long. And I think, as Kevin said before, we're really welcoming the questions that will come via the chat route, and we can have a discussion about anything necessary afterwards. So hopefully onto the content of the presentation then. So the presentation today has got 5 main chunks. I'll talk a little bit at the start about myself and about how I ended up in the position I am at the moment with the responsibility for longitudinal timbers. Then I spend a little bit of time talking about recent incidents and issues, and we talk in specific detail about 4 particular examples, 2 of which are derailments where longitudinal timbers were a cause or a factor within those derailments, and 2 of them are block the line faults, which had quite a significant impact on our ability to run trains as we would like to and should do. The third part of the presentation is about common issues. So some of the things that we've learned and identified to be common amongst lots of the failures and issues that we've had through long timbers. Then I'll talk a little bit about what I call our roadmap or our route map to success, which talks about where we come from and where we're going to, and the different bits of technology and ideas we've got for the future. And then finally, in the very last slide, I'll talk a little bit about the new technology, which is making huge improvements to the way that we manage and maintain longitudinal timbers. So hopefully all that will take us about half an hour to talk through. And if you know a lot about long timbers, then hopefully you'll be able to pick up on a couple of new bits of technology that will be coming soon to kind of the world of long timbers. And if you know very little about long timbers, hopefully you'll take away a bit of knowledge about why we're in the situation we are in and why we're focusing so much attention on the kind of improvement to the management of long timbers. So I wanted to quickly talk about me very briefly, just to let you know that I've been in network rail now for 13 years through a whole host of different kind of placements and opportunities and roles, including some time with high output in assurance engineering in the L&W South RAM team, as was back then, and then most excitingly as track maintenance engineer for London Euston area for 3 years, which was such a brilliant opportunity and a great chance to get familiar with longitudinal timbers, and also of course in a very challenging area, so plenty of learning was undertaken then. And then for the last 2 years I've worked for the technical authority in Milton, Keynes as a senior engineer, and part of the portfolio of work that I inherited when I joined the technical authority was the ongoing rewrite of the standard TRK 3038, which was titled back then Long Timbers, the Design, Installation and Maintenance kind of guide, as it were, or standard. So that sort of led me to the position I'm in right now, which is obviously presenting to the PWI about what I've learned and where we've come from. And I think I just wanted to add to the end of this kind of introduction that my passion within the railway has always been about trying to share knowledge and learning from different opportunities and people and experts, and I'm especially keen on sort of track system engineering, and I suppose longitudinal timbers are a brilliant example of where a system has to work. It's not just about one, I mean they are just one component, but the whole track system of course is reliant on everything that sits underneath them and everything that sits above them. So there's been plenty of opportunity to learn while I've been trying to get my head around all things long timber. I think it's worth at the very start of the presentation as well being clear about what I mean by long timber, because they go by a whole host of different names, including way beams, long bearers, wheel timbers, composite balks, and all kinds of different names depending on which part of the country you're in. So generally, the longitudinal timber is the bit of wood that sits underneath rails in a longitudinal direction, so not a cross timber or a sleever, but the longitudinal ones. And they're generally installed, or generally they were installed, in areas where ballasted track solutions would have had too much depth or would have been too heavy for the proposed or the intended structure. So they're a sort of lighter and thinner way to manage the position of track over particular structures. What we find is probably the main cause of issues around long timbers is to do with gauge loss, which is really simple, you know, a very, very simple thing to understand and to see. But the really interesting part is how do we get to that position of gauge losses, and what is what are the root causes? And that can generally be to do with movement between the rail and the long timber, or it can be to do with movement between the long timber and the structure, or I say movement, rotation, or movement, or it can be for changes of track stiffness from ballasted track onto a long timber, or it can be because of structural issues, so you know, movement of the structure on whole. But it all looks kind of simple from the very first thing to say gauge spread, but of course the reasons for that, as we always know with our track systems, can be far more complicated. So as promised, we're going to spend a little bit of time talking about some of the derailments and issues that we've had around long timbers in the past. So this one goes back to Paddington Station back in August 2017. So the RAID did the kind of the full and thorough investigation into this derailment, and for a bit of context, it was the rear power car of an Intercity 125 high-speed train, which was on platform 2, where both wheels of the leading axle for the power car and the right-hand wheels of the trailing bogie derailed due to gauge spread, as I've mentioned before. And it says also quite specifically that the train derailed because the right-hand rail moved laterally under the weight of the train. So the longitudinal timber there enabled the movement of the rail, which of course moved under the train. So obviously derailed because of the gauge spread there. What's interesting about the short report that the RAID produced following this is that the right-hand timber, I'm reading a quote here, sorry, the right-hand timber had decayed to the point that they were no longer able to maintain the alignment of the track as the train passed over them. The failed timbers had been identified as needing replacement during their preceding detailed annual inspection, which had been carried out by the local track section manager in 2016. The inspection report recommended that approximately 30 of the racks should be changed as practical. So this is something where we knew the condition of the long timbers would or could likely lead to some kind of incident, and we were unfortunately proven wrong or not correct in this case. Now, for me, this was the sort of the starting pistol in the long timber project, because it was this incident that led to the prioritisation of the rewrite of the TRK 3038 standard. So this is kind of where it stemmed from. It's also worth noting at this particular location that the detailed examination of the timbers at Paddington Station was made more difficult because only 2 faces of the timber were accessible to visual inspection. So of the whole of the cross section of the timber, only 2 faces could actually be seen, which makes obviously full and thorough visual inspection quite difficult. And the decay that was present on the underside of the sleepers, i.e. where it was worst, was completely hidden. So you know, an inspection personnel did well to identify that the timbers were inadequate, considering that they were unable to see most of the hidden elements where the significant portion of the deterioration was. What's interesting also is what followed this particular derailment is that the route involved, Western, did quite a thorough inspection of all of their timbers following the derailment. So I think this inspection sort of concluded around 2018, 2019, and identified that of 804 timbers, there were 201, which is about 25%, that required replacement. So some of those were in 3 months, and then some of them were within 12 months. 131 of them, so 16%, required enhanced inspection. So in other words, doing more than we were doing at that particular time in order to monitor any deterioration or decay. And then the final 59% required no treatment beyond normal maintenance. So it kind of says that almost half of the timbers that were identified needed something above what was current maintenance regime, and in some cases that was as significant as needing replacement within three months. The pictures that you can see, the most significant important one is the one in the middle, which is the long timber that shows the underside of the decayed long timber. So you can see kind of the extent of that decay and what was causing the movement of the rail. So the rail was attached to the long timber and the timber was moving, thus allowing gauge spread to happen. Okay, the next derailment I want to talk about is at Wanstead Park, which happened on the 23rd of January 2020. Now, there's a big disclaimer whacked across the front here because I need to be really clear that I think Regulation 13, paragraph 5, says that the details of the report that comes from RAVE are confidential and must not be shared with anybody. So I have to be careful about what I say, basically, because what Network Rail does know about this derailment are things that we were able to establish as part of our own internal investigation, which I'm able to talk through. So depending on what you might know about the derailment and what you might have read elsewhere, what I'm saying is that there could be a difference between what I say and what the RAID say, and that's because I'm unable to talk about what's within the RAID report at the moment because of the timing. However, Dr. Mark Burstow is giving a PWI talk on the 3rd of December all about derailments, and I'm not sure that he specifically references this one, but I know if he can talk about it in detail, then he definitely will. So everything that I talk about from now on is taken from or taken as part of the investigation that I was a part of into the derailment. So it's worth noting at the very start of this that the vehicle involved in the derailment couldn't be inspected as part of the Network Rail investigation because it was quarantined by RAVE. But it was recorded that there could have been an indication of a problem with the rotational stiffness of the wagon, of the wagon's bogie. So it was suspected that there might be some issues with the wagon itself, but we were unable to test it and to explore that kind of hypothesis fully. Because of the kind of suspected issue with the wagon, there was this sort of suspicion that there could have been increasing forces applied to the rail when it was negotiating certain directions of turn. So if the bogie was a bit stiffer than it should have been, then the wheels would obviously have exerted a greater force onto either the left or right hand rail, depending on if it was going around left or right hand curves. But of course, the wagon was fully investigated as part of the RAVE investigation, so the results of that will be available when the report is made public. Other things that we know as fact about this particular derailment then are the train was running at 22 miles an hour. And the sequence of derailment is really interesting in this case because there was two wagons involved. There was kind of a front wagon and a behind wagon, and it was the trailing bogie of the front wagon which one of the wheels derailed first of all. That spread the gauge wide enough to then derail wheels from the second wagon, the following wagon, which derailed for a short time and then ended up re-railing. And then following that, the leading wagon, the trailing wheels both derailed, as you can see in the middle picture there. So it wasn't just a case of one wheel derailing over a long distance. It was a case of multiple wheels derailing at different times over different distances. But the most significant damage was done by the first wheel to derail, and then the other one that you can see in that picture there, so on the same bogie. So I think the kind of overall distance that the derailed wheels travelled was about 2 miles and 965 yards, which kind of did quite a lot of damage to the kind of the plain line railway, and also annihilated something like 7 longitudinal bridges damaged along that particular piece of route. And there was a repair cost of nearly £8 million while the route was closed for sort of 27 days while we were looking to repair that. And I think the picture on the right kind of gives what would be the biggest indication of why the longitudinal timber was implicated in this derailment. You can see that, and obviously what we've done there is we've taken it to a separate site for dissection and further analysis, but you can see that the capacity of that bearer to withstand the loads that were applied to it was vastly reduced by the fact that it was so badly decayed from the bottom up. What we know about the bridge is that there were areas where there was water trapped within the structure. So, you know, we kind of made the perfect conditions for decay to infiltrate the long timber and then get worse over time. We also know from the inspections that there was some splits and cracks, as you can see on the picture on the left, that were visible before the derailment, but of course made far worse by the derailment itself. So the timber wasn't in the best condition, but what you can see on the top of the picture on the right hand side is that actually from the very top of the timber, it doesn't look quite so bad. You know, it just on a quick visual inspection, you might look at that and you might tap it and you might hear something that sounded like it was a quality sound timber, or not something that you'd be immediately and significantly worried about as a kind of immediate concern, and you know, a block the line and want to cause disruption, etc., etc. I'll move on now to the third incident, which wasn't a derailment but was a block the line fault identified at a viaduct called Esneal Viaduct, which is between, my apologies, I haven't written down where it's between. Oh, here we are, between Sellafield and Boozle, in the north part of the northwestern central region. So the kind of order of events here was quite simple, in that the track maintenance engineer and the section manager did an inspection of the bridge and noticed a deterioration in the timbers on one of the lines, and applied a 5-mile-an-hour ESR because they were concerned about the condition of the timbers. Following that, there was some discussions over how bad that deterioration was and whether or not they should kind of apply for a kind of enhanced inspection regime there, which was undertaken. So they did a much more thorough inspection following that original inspection, with a bit more time and a few more bits of information and tools. And then as part of that inspection, they went to observe the longitudinal timbers under load, so with traffic moving along them, and were so concerned about what they saw in the movement. As they saw a freight train traverse on the down line, there were indications of vertical movement, and on further inspection, the line was blocked. So all the damage that you can see in those two pictures there was what's the word? Done by a spanner and a boot, basically. There was no you know, machines that had damaged this particular bridge. It was just by giving a bit of a tap and a kick and kind of seeing what fell off, and that level of decay on that particular bridge, obviously exposing the coach screws, etc., is enough of a concern to want to make sure we take the right action to block the line, so that we can make a repair and fix it as quickly as possible. There's now been kind of a long piece of work undertaken to replace nearly all the timbers on that particular structure. And of course, what I'll talk about later on is how we've changed the inspection regime now, so that we shouldn't ever end up in a situation where something is identified, you know, years out for replacement, and then deferred or pushed through a work bank or held onto for a bit longer. So it ends up in a situation where we block the line because it gets to a situation where we're unable to maintain it safely any further. Okay, and then the final incident that I want to talk about is the river Fluffer, perhaps Fluffer, in Wales. So this one was quite recent, in that it was the 7th of July 2020, and the bridge is quite a simple bridge. I think there's just 4 timbers there, 2 on the left, 2 on the right. And there's a bit of an interesting history here, because what we were able to find out from using our asset data is the timbers were installed back in 1983, although there is still some real question over whether that's accurate data or not, because there's other signs that imply that they were installed quite a lot later than that. But our own records show they were installed in 1983, and there's a suspicion that might not be correct. Again, it's a very similar story to the Esneal block the line fault, where a supervisor's visual inspection was undertaken, and they noticed a deterioration in the timber condition. A more intrusive inspection followed that, using a screwdriver to probe further, and you can see again the damage. Some of that was done before the screwdriver, and some of it was done after the screwdriver. But in no situation should we find ourselves in a place where we can destroy a timber that well just by using a screwdriver. That was on one particular timber. In fact, all the damage you see there is from the same timber, but the other 3 timbers were in a not quite as bad but similar condition. So the action was taken to replace all of them. Another interesting thing about this bridge is that it's often been subject to flooding, so it's been wet and then dry and then wet and then dry at particular times over the past number of years. And most interesting, I suppose, is that there were gauge spikes visible on the trace from as far back as maybe 2015. So lots and lots of kind of clues and indicators that all might not be well on this bridge, but perhaps we didn't take action on working out exactly what the root cause of those faults were well enough to be able to fix them before they caused us a problem. The other thing that's noteworthy about the inspection regime here is that the inspections were generally undertaken without loading, so we didn't necessarily observe trains moving over the longitudinal timber structure, which probably would have helped us to identify an issue on site before it became an issue for us in the scale that it did. So I wanted to briefly talk about some common problems across all those sort of derailments and longitudinal timber issues that I've just mentioned. So what we were able to say is that visual inspection alone doesn't give us enough evidence to robustly determine the condition and bearing capacity of a longitudinal timber. The picture on the left is taken from Waterloo Station in platform 6 earlier this year. So unfortunately, I don't have a picture of kind of the top down, but you can just about see at the very top of the picture there, that's the actual surface of the timber, as in the bit that an inspector could see. Because it was in a trough, so not observable from either side or underneath, obviously. But the bit that the inspector could see generally looked okay. The inspector told me that to tap it with a hammer gave back a sound that was not an immediate sound of hollow timber underneath or a significant decay at the top. And that's of course because when you sound a timber and tap it, you're only testing the timber that's immediately beneath it. It's not a robust tool for testing the integrity of the entirety of the timber. So like I say, also other signs there say that only a few of the fixings were even loose on that particular timber, so less than 10% were loose, and the rest of them were all kind of holding firm and tight in the right kind of position. And based on a visual inspection, the timber was given a 4-year life expectancy. Of course, once an adjacent timber was removed, and people were able to see like the level of decay there was inside the timber, and the fact it was predominantly hollow, it was replaced immediately. But from that kind of basic visual inspection, given a longer lifespan than it probably should have been. I'll talk a little bit more about that particular case in a short while when we talk about the solutions to some of our problems. On the right of the screen, there is one of the timbers taken out from from Wanstead Park, the derailment there. And again, I was able to get a picture from the top and a picture of the side of this one. So you can see, again, looking at it, how visual inspection at the top there shows, yeah, there's some cracks, but it doesn't necessarily indicate the condition of the inside of the timber. Of the timber. So the visual inspections don't give enough evidence to robustly determine the condition and bearing capacity of the longitudinal timber. And we also know that crude methods to examine timbers deliver crude results. So simple methods to examine a timber obviously result in simple results that perhaps don't give us the best indication of the actual condition of the timber inside. We also know that visual inspection cannot detect internal voids, i.e. areas and pockets of decay, and way beams, or long timber, are too large cross sections for hammer soundings. And also, of course, the fact there's base plates and rails in the way means that you can't test everywhere that you want to be able to test. So I won't spend too long looking at this slide, because I realise I've presented it to probably half the population of the planet so far, but I do want to quickly talk through where we were, which is in the top left there, about the Paddington derailment, and where we are hoping to get to, which is box 19. So it's kind of like a journey for us. The Paddington derailment kickstarted many different projects to improve the level 2 standard, which is TRK 3038, and of course inspection techniques associated with that. We also took steps to improve the competency framework and composite materials development, which I do touch on a bit later on. That happened over that kind of intervening period. Wanstead Park was a real shame that it happened, but was a good reminder of why we were taking the action we were taking and how much more I suppose there was to do. But it was once a park for me that kick-started this kind of roadmap of everything else that we needed to do. So since then, we published a new standard, which is TIK 3038, which includes a couple of changes, which I don't go into too much detail on, but it forces engineers to write a longitudinal bearer management plan, TEF 3279 that is, which has sections to talk about the makeup of a particular longitudinal timber bridge, so integrations with structures and particular specified components. It has an opportunity for an engineer to record the condition over periods of time, and critically, it forces an engineer at the end of the process to say, we believe that there's this much life remaining in these timbers and this structure. Then we also mandate the use of non-destructive testing, which I'll talk about a little bit later on. We mandate the use of observation under load, so to see vehicles running over a longitudinal timber bridge, and there are improvements to TEF 3014, which is the detailed examination TEF, which makes it work in a bit more of a logical flow, so it's a bit easier for a user to fill out. And critically, it makes a distinction between a detailed examination, which would happen once every year, and then the supervisor's visual inspection, which happens in line with the normal inspection frequency for that piece of track, so every 8 or 13 weeks, depending on the track category, etc. Moving on around the rest of the roadmap then, we piloted the RBC long timber course, which is still kind of in its last stages of development and rollout. And then we finished the kind of the last step, as it were, towards composite materials as well, which I do talk about a little bit later on. So they have a longer lifespan than timbers. They're workable like wood, and they can be made from, in some cases, part recycled material as well. So not so bad for the planet. We completed the product acceptance for the micro drill, which I'll talk about a little bit later on. We issued a SIN, which is a special inspection notice, which forced all engineers to go and do a tactile inspection of their most high-risk longitudinal timber assets. So this is a case of visiting every long timber asset that we have concerns about across the whole of the network, just to verify the condition and also plan and prioritise any work that needs to be done to make sure that we can continue to operate a safe railway. Then we are doing at the moment a post-implementation review of TIK 3038, which is just taking back a bit of user feedback from the standard we published earlier in the year to make sure that it is fit for everybody to use and includes the right information. We're hopefully going to kickstart soon some research into the decay of timbers, which I'll talk about a little bit later on. And then moving around the corner there, Ellipse is an internal system we use for recording asset data. So we're looking to do a better job of that to hopefully improve our kind of asset knowledge and information so we can make better decisions in future. We're running a system of raise the bar training, which is about providing very quick training to as many detailed examiners and users of, inspectors of longitudinal timbers, so that we can very quickly give them a better competence in identifying where weaknesses might be in their structure and ways that they can solve those problems. We're publishing some new track work instructions. We have created a new detailed examiner's competency specifically for the once per year detailed examinations, and that process is really flying along at the moment, so that should be available to colleagues in Network Rail in early 2021. And then we're looking at the improvements being made to the inspection competencies and the supervisory inspection competency. And then finally, in future, we're looking to do some ongoing assurance of our management of longitudinal timbers through different regimes that are important to note. So next up then is, what does the future hold for longitudinal timbers and the management of them? So there's a couple of different things. I said I'll talk about a research project that we're looking to instigate. So this is about, there's a few different objectives, but one of them is to understand the rate of deterioration.
John, just before you go, just before you go on,
ways to stem, prevent, or prolong this. So what we know is that there are different kind of treatment.
John, there seems to be a few problems with the audio at the moment.
Okay.
We can't hear you, John. Do you want to try dialing in, John?
Yes, John, you appeared to drop out for some reason about 30 seconds to a minute or so ago. So,
Hi John, it's Sarah from the PWI. Do you want to try dialing in?
hello, can everybody else hear me at the moment?
Yeah, we got you, Kevin.
Yeah, we can.
Loud and clear, Kevin.
Thank you. So it appears to be
No problem.
too loud and clear. Okay, it appears to be a it appears to possibly be a John issue then.
Yeah, I was hoping he could dial in.
Can anybody hear me at all?
You loud and clear, John. Loud and clear.
Oh,
mate.
brilliant. So sorry about that. I literally don't know what happened, but I'm pleased you can hear me now. So I'll crack on with where I was. We're very near the end though, so bear with me. I think what I was talking about was the research project that we have, the future of long timbers and the research project that we have looked to start, where the objective is to understand the rate of deterioration of timber assets and ways to stem or prevent this. So what we know is that a pocket of decay will have an impact on the ability of that timber to undertake its role. And what we don't know very much about is how much decay we can tolerate. So industry sort of guidance says something around 20% is probably a limit. But like I say, we don't know what that is for a long timber. We don't know necessarily whether the location affects it significantly. And we also want to know more about whether it's under one base plate or multiple base plates and what we should do in those particular situations. So the kind of ultimate outcome of the research project should hopefully be something akin to an action table that says, if you imagine a matrix that had the kind of percentage of decay along the top and then the area that it covered along the left-hand side, that had a kind of a green to red sort of scale that said, do something very significant if it's down here, but then do something less significant if it's up at the top. The other thing that we're asking that research project to do is to look at the impact of different preservatives. So, for example, using a boron gel to stem decay or to prevent it from getting much worse, to stop the rot, so that we allow ourselves more time between renewals, etc. The next new piece of technology is a micro drill. So that's what the picture shows there. That is a tool that measures resistance, basically, really, really simple. It pushes a very fine kind of millimetre thick needle into the timber. It measures the push that's put on the needle to go forwards into the timber and also the resistance to the rotation of that needle, and then plots it onto a graph, which I'll show you in a couple of slides, or in a slide's time. That tool there, for the first time, gives us a real indication of what the condition of the timber is like actually inside. So, it's not just a visual look or a tap with a hammer. It's actually saying inside your timber, you've got pockets of decay or you've got completely solid, good, sound timber. The next thing is that you can see there a little picture of a camera. So this is only a kind of a minor thing, but that particular camera there, it only costs about £400. It's motion activated. It gives HD high definition footage. It's powered by solar panels, and the images are instantly uploaded to a 4G network, which means that, as I was saying earlier, one of the things that we don't do as well as we should do is observing timbers under load. And I don't know if this will load very well if it's played through Wi-Fi, but there's a very short, literally 4-second video, which you might be able to see in a second, of just the kind of the quality of that particular recording. So I'm not sure if anybody saw that, but if you do want to see it, I can send you a link to it in particular, and you can see kind of the quality of the video footage that we get. But what it shows is that the timber effectively bounces up and down as a train passes over it. So there's lots of movement there, which would be a sign and a concern for us to do something. Then the next bit of the future I want to talk about is composite materials, which I really do think are the future of long timbers or longitudinal bearer systems, even because there's loads of benefits to them. They're workable like wood. They can be drilled and planed on site. Take into consideration some of the safety management systems we need around them for the dust and the different bits and pieces that are used there. They don't decay at all, so there's absolutely no decay in them, which gets rid of one of our biggest risk factors with longitudinal timbers. Because of that, we could reduce the scope of detailed examinations and push them out at much greater timescales. They're not flammable, and ultimately they lead to a longer time between renewals and hopefully a reduced maintenance intervention. So increasing capacity and reducing costs, which are two things that we're obviously very, very keen to do. I think in the final slide, I wanted to talk very quickly about the micro drill again. So that was a timber I showed you earlier at Waterloo Platform 6. And this graph here is the output of, it's actually not the micro drill we use here. It's a very similar product called the resistor graph, but they both do the same thing. And this micro drill or resistor graph output shows, hopefully you can see on the side there quite clearly, where it measures a really high resistance, i.e. where there is timber, where it measures no resistance at all, i.e. the hollow bits down there. And that's why I'm so pleased and proud to see that the micro drill is finally rolling out with training across the infrastructure, so we can start to get a detailed and good look inside so many of our longitudinal bearers and timbers. The final picture there, I think, comes from the Wanstead Park derailment again, where you can see the output of the micro drill held against the cross section for where it was drilled, and you can see where the spikes and the areas of decay, the spikes in the graph show there's more resistance, i.e. it's a stronger timber, and then the graph shows that it's there's less resistance and more likely to be decay. And in fact, the software that comes alongside the micro drill actually shows you where. It gives you a percentage of decay through the timber as well. So we are absolutely not talking here about taking the decision out of an inspector, a detail examiner's hands, because that's not the right thing to do by any means. But we are saying, here's another tool in the armory. Here is another piece of information you can use to make a better decision on the condition of that particular long timber. I don't think I mentioned before, but the axes for the resistor graph show going up the left-hand side is the amplitude, so the measure of resistance basically, and then along the bottom is the depth that it drills, as you can see on the one that's overlaid onto the Waterloo timber just there on the left of the screen. And then finally, the very last thing that I wanted to talk about very quickly is what we've called these long timber open forums. So since we started researching more about long timbers and finding more kind of the failure mechanisms and the solutions to those and practical ways to manage long timbers effectively over a long time, we started running these long timber open forums, and we've had a couple of them so far, and they are a chance for people who have got an interest in long timbers or an opinion on them to dial in and to talk about them just openly, to raise issues and challenges that they might face with the management or the installation or the repair of long timbers, and also to be listened in their concerns by members of the working group who are dealing with the long timber project. So again, I'm really happy and proud that we've been able to roll out these long timbers and be able to listen to kind of a cross section of the railway community. on what their concerns are with long timbers, so that we can focus our attention on the right thing in future. And that's how things like the camera got to see kind of the light of day, because it was raised as a concern, and a solution was kind of proposed and investigated following one of these open forums. And they really are an open forum to turn up and discuss whatever you like or want to discuss. So that's the end of the presentation for long timbers. My apologies again for the sound issues partway through. I'm not sure what happened there. But hopefully you managed to get some bits of information and hopefully knowledge from that. And as Kevin said at the start, I'm more than happy to take any questions people might have about long timbers. So please do mention them from the chat, Kevin or Ian or Sarah.
I've got a number of questions that have already come through. Timothy Knight has asked, "Hi John, any lessons for track designers here? Is there anything we should be specifying to help control this risk through the design process?"
So track design, what I have realised since presenting the roadmap to lots of different people and places is it says that we're going to do a lot, but it doesn't say that we're going to do enough. Like, there is so many more areas that we need to take this. I've been made very aware that we don't provide the best information, guidance and help to capital delivery in the installation of new long timbers. We don't necessarily have the best regime set up to help people who are delivering maintenance on longitudinal timbers, and also quite rightly, not rightly, but you're quite correct in saying that we don't yet have information that's ready to be pushed out to say, in doing track design, these are the things that you should consider. So it doesn't yet sit on the roadmap, but it will do eventually. But I will say one other thing though, that where we started was with inspection, and I make no apology for that, because I think getting the inspection right and understanding what the condition of our timbers are probably is the most important thing we can do first off. We have years of history and good knowledge of designing and installing and repairing long timbers, but where we've proven to have been let down or letting ourselves down a few times is in the kind of the adequate inspection of them. So getting inspection right is first, and then other things will follow in future, is the plan, at least.
I've now got a question from Andy Savage that was then followed up with another one, and I think subsequently some other questions relate to this. John, the Festiniog Railway has made considerable use of recycled plastic for plain line sleepers and S&C timbers. After several years, the feeling is that they are a good thing, and they look as if they will give a longer life than new Jarrah. He then followed up with any views on the suitability of such materials for standard gauge long timbers, which in a sense you have sort of answered, but you might like to expand on that a little bit.
So I will just kind of reiterate the point that I tried to make earlier, which is I think that composite materials for longitudinal timbers really are the future. So I don't know why in this day and age we would continue to chop down ancient old hardwood trees to chuck them under our railway, knowing that they ultimately will deteriorate or decay to a position that we won't be able to use them, when we've got a proven method for longevity of a particular material, and a proven ability for it to hold gauge where it needs to be and to not deteriorate. So I'm fully in support of them, and want to see more of them, even if it is talking myself out of what could be a long and beautiful career in the management of long timbers. I'm happy to forego that to have a better product installed in our track.
And then on a slightly different facet to the same thing, Peter Halliwell. John, thanks for a very interesting and well illustrated talk, and a classic example of the mismatch between a decay mechanism and the ability of the inspection regime to identify that decay, the risk and the response needed. Whilst we will have a large population of LTs for many years to come, what are the initiatives to eliminate LTs from the track system?
Interesting topic there. So what the new TRK 3038 does is prohibit the installation of new longitudinal bearer systems. So we are not able anymore to build a new bridge that has longitudinal bearer systems. It must be a ballasted track or other approved track system. So long term, there is no initiative that I know of that will, one by one, that will do a good job of removing these long timbers en masse, but one by one, bit by bit. Over the next ice age, I imagine we should see them slowly removed from track by the fact that the bridges will need to be replaced, bit by bit, and we've removed the ability of people to reinstall longitudinal timbers on brand new bridges. When it comes to things like bridge deck repairs, where the kind of the structure of the bridge isn't being changed and the same depth restrictions and weight restrictions exist, then obviously we've had to say that long timbers can be replaced in those cases, but not where bridges are being designed as new.
I think the question we've had from Samuel Allwood over methods of non-destructive testing has been John's answered. There is one on a non-destructive testing process which may not have been considered, from Joe Buckley. Wondered if NR have investigated use of low-frequency ultrasonics to find internal decay. I've worked with R&D groups for identifying decay inside trees and historic building timbers. If you have access to two opposite sides, it might be useful.
Yes, so interestingly, I talked with Trada about this because we were looking for the best proven method, basically. As in, you can probably tell from the presentation that we had to take action quite quickly. So I was looking for the best proven method that would give us the best indication. So there's loads of limitations of the NDT that we will do with the microdrill, in that it doesn't cover, it's like ground investigation, I suppose. You do one and you assume it's the case for 100 meters of track or something. You take one drilling that's a couple of millimeters wide, and you have to assume that covers a particular area, and you could miss a pocket of decay. So the process we're looking at using says do something visual first of all, identify the areas that look like they might need some more treatment, some more investigation, take a couple of measurements between those as well, almost as random, kind of, see what the timber's like in the middle in these extra locations. And then investigate in detail the areas that you've identified through the visual inspection. But ultrasonics would be fantastic for giving us a complete picture, a bit like ground penetrating radar for trackbed investigation. Would be absolutely fantastic for giving us an entire picture of all the decay across timbers. But of course, it's limited by having access to different parts of the timber. So where you've got it in a trough and you've only got the top surface, we weren't able to say it was a proven technology to demonstrate where there was decay. Because it was affected by too many variables, including the material that surrounded it, the environment it was sitting in, different levels of moisture, etc. But definitely somewhere that I'd be keen to go in future, because I think having that full picture of a timber is the only thing that will ever give us absolute certainty. We know exactly where decay is and exactly what the impact of that might be. But the reason we chose the microdrill as our NDT is because it works, it's ready, it's been proven to be used. BT use it on their 4.5 million telegraph poles, it's proven and works.
I've got a question from Carl Baker with regard to arrangements for holding the track in place. John, great presentation so far. Have you a view on holding down arrangements, and if drilling holes in the timber causes more decay? It is sometimes difficult to propose an alternative arrangement if that alternative is a strapped system, which in effect would mean more parts to maintain, etc.
Yeah, so drilling holes in the timber is definitely an area that of water ingress, basically, and definitely an area where decay can stem from, and we've seen countless examples of that. What we were looking at, or what we are looking at even, is using, as I mentioned, a boron gel. So something that will diffuse over time in a hole that's been drilled for a corkscrew, for example, and then would help to prevent decay and deterioration from forming at that particular point. So we haven't looked at alternative holding down arrangements, no. I think that might be perhaps a step too far for my simple mind to cover, but we are looking at different ways of preventing decay from occurring in areas where we know there's going to be water ingress into the timber, because it doesn't make very much sense to have this timber, covered in a preservative when we buy it, and then drill holes all over it and chop bits out and not preserve those, and then expect it to last as long as the rest of the timber. And we know that. We just need to be better at avoiding it.
I've still got some more questions on composites and FFU. In passing, yes, we are using Network Rail are using FFU, and as been pointed out in sort of responses, Newark Flat Crossing has used this method of timbers, and there are a number of other places where we're trying to use them. But question that's come from Liam Jackson: John, what are the barriers to making composite longitudinal bearers business as usual?
Interesting. So there's a few different things. I think roll back a couple of months and there was some kind of supplier side issues, you might say. There was a couple of contractual things that stopped us having them readily available to be installed, but those are mostly achieved now. So we're in a better place for installing them or getting them ready to install. I personally think that there is kind of a, if I called it an education issue, that's not to be patronising. I mean, just to educate people on the benefits of them and why they would want them to be installed, because we're asking people to go away from their norm. And you know what they know and what they've worked with for years and years and years for a new material which involves a new installation methodology. So I think there's that education thing. And then my third point about what's stopping it was to be the information that we can provide for the kind of the long-term inspection and maintenance. I think from an engineer's point of view, it possibly could still look like a bit of a gamble with FFU, composite bearer materials, because the support we can offer and the guidance and the years and years of history and information exists for timbers basically, and composite materials haven't got that the kind of the bank of track work instructions and the, if you notice this, do this, it's all a bit of a learning curve. And I can see how that would be something a person would consider if they were thinking about putting these new timbers in. I'm not sure also that our actual direction, so I'm not sure also that as a company we have said yet, if you're putting new timbers in, we insist and demand that you use composite materials. The clear direction isn't there yet, and I assume that comes because we're still working on the education and the information part of it. The competence of people to be able to install them, as I mentioned, could be a bit of a risk. But I don't think there's one reason as such. I think it's a reasons which we've got to just tick off one by one, and probably the best way to do it is by working closely with engineers as they engineers and renewals, capital delivery contractors to make sure they get specified and try and hear their problems and fix them as quickly as you can.
Now, hot off the press by the looks of it, as Gareth Evans has replied to someone else chat question they raised. Thanks, Patrick. I can confirm that we, NR, have just let a contract to Sikitsu for BAU supply of composite materials (FFU) to replace timber in longitudinal bearer systems. Full product acceptance will be authorised by the end of December. We're planning briefings across our new regions to support wider use of the material.
He's very good, he's Gareth, isn't he? He's on the ball.
Yep. And then I've now got a question from David Packer. When considering further enhanced ability to test long timbers in situ, it's important to look at the residual risk that is being managed. Post-implementation of the new standard will reduce risk from the current. Post-implementation of the new standard will reduce risk level from its current level. There should be a full risk and financial assessment of the benefits and costs of any further new methods of testing.
So interestingly, there absolutely was a cost benefit analysis done as part of the rollout of TRK 3038, and that showed a cost benefit to Network Rail from the better management of longitudinal timbers. So we, the considerations were massive. We said buying the drills is nearly £750,000. The trading on top of that will cost X number of thousands of pounds. There is more work for an engineer to do, and I don't apologise for that. There's more work for an engineer to do to make sure that their systems are good and they have good data on their timbers, and they're making proper decisions for how long a timber has got left its residual life. But you stack up all those costs against the cost of the derailments that we've had just in the last couple of years. I think we looked at a 3-year time period, although I'd have to check my maths on that, to say how much has Network Rail had to pay for the the repair of the track following these derailments, for the schedule for cost of closing down the railway unexpectedly, etc. And there is a cost benefit to regions from implementing the new standards. We come off as a company after the end of control period 6 in a on paper, in a better financial state because of our better management of longitudinal timbers. And I fully support the idea that we shouldn't ever be changing standards or making new instructions or ways of working if we're not doing a total cost benefit analysis. But this one, I'm pleased and proud to say, actually comes out positive for us.
David's responded, thanks, a very helpful response. I don't know whether anybody else has got any more questions. If not, I'd like to ask Ian Griffiths to thank John.
Yeah, no, thanks, Kevin. Yeah, it was really insightful presentation, John. I loved the way that you almost answered all the questions that came up on the chat as you were going through it. Really, you would sort of explain what the problem was and then all the solutions that are being put in place. So I think if everybody could join me in thanking John in the usual way. Thanks, John.
Thank you all. It was a real pleasure to present. I think the very best way to learn something is to try and present it and teach other people about it. So, it was a real pleasure to do this. So thank you for taking your time to listen and offer feedback and questions.
Thank you, John. There was one